All right, I think we will get started. Good day, everyone. My name is David Failing. I'm with Lucas Diesel Systems, and on behalf of Lucas, I'd like to welcome everyone to this second webinar of 2025. We have quite a very good presentation again today by Tony Salas. But before we get started, I'd like to just go over, as usual, all of our housekeeping items. Um, we will supply you with a certificate of participation for this event here, for this webinar, providing that you are on until the end of the webinar. So just stay tuned till the end, and then tomorrow or the day after, we will be sending out certificates. In order to reduce any distractions, we have muted everybody. If you have any questions, if you'd like to post them in the chat or the Q&A section at the bottom of the screen, that would be great, and we'll get to that either during the webinar or if not here towards the end of the webinar. But before we get started, as you can see here on your screen, we are very, very pleased to announce a new catalog, as you can see here. And the QR code that's on the left of the screen, if you use the camera on your cell phone, you can download that catalog digitally. And the catalog contains a whole new package of parts, injectors, accessories, and so forth that are for light duty as well as medium duty and heavy duty systems. The light duty being the Ford Power Stroke, the Dodge Ram with a Cummins engine in it, the Duramax engine, and the Power Stroke being the 6.0 Power Stroke, as well as the 7.3 Power Stroke. As you can see briefly from this catalog, we have a whole array of products. We have the complete reman injectors for all of these applications on the light duty, as well as fuel lines, replacement lines, sensors, seal kits, regulators, glow plug modules, IPR valves, and injector return lines. That's just a few of the items that we have here that we're introducing in these new catalogs. So as I say, you can just click on the screen here, download the catalog digitally, or you wait till the end. We will supply you with an email address of Erica's email as well as my email. You can send us an email with your name, address, and we will send you a paper copy of the catalogs. Also, as you can see here, this is just a caption of the internal portion of the catalog. The injectors are available in single injectors or in sets of 4, sets of 8 injectors. And as you can see here, as I said earlier on, we have medium and heavy duty parts available for all of these new applications. In addition to that, we have agricultural applications, as you can see here, the fuel injectors, as well as the line seal kits, a complete array of common rail high pressure injectors available, and all of these are reman injectors. The parts being new parts and seals and so forth are new parts, but the injectors are all reman injectors, all remanned in the US. In addition to that, we have available turbochargers. Turbochargers are new turbochargers, and the nice thing about this is that we don't require the core back. So the core is entirely yours to keep if the customer returns the core to you. So with that said, I'd like to introduce Tony Salas. Tony is our presenter as usual, and he's a veteran technician with a shop and training facility in Las Vegas. Tony has been training for a number of years now, probably in excess of 30 years. And his presentation today is entitled Case Studies, a look at various diagnostic scenarios from Power Stroke to Duramax and to Ram Cummins applications. So Tony, let me stop sharing my screen and I will let you share your screen and get started. Thank you very much, Tony.
Thank you very much, Mr. David. I guess I'll put mine up there. All righty. Well, thank you once again. It is now towards the February 18th. I was going to say January, February 18th. It's been interesting still on what's going on in our arena of light duty diesel and medium duty diesel. As you all know, I've been doing a lot of training here, but I thought I'd make a presentation on case studies. Some of it is old, some of it is new. When I was putting this together, I said, well, what are the common things that I'm finding out? And one of the things I'm going to be talking about, for example, is I was talking to another instructor and I said, it's kind of funny how I see these issues. And I was surprised that a lot of techs still didn't know how to do the suction test on a Duramax. So if some of it's a little basic for you, my apologies, but there's many that actually need update on the older technology, such as even 6.0 power strokes. So be patient here as we go along here. But as we get started with the case studies, and obviously this is all about diagnostics, please note that as I discuss all these different case studies, a diagnostics process has been performed. A lot of these I was involved with. Actually, most of them I was involved in. And but as we deal with engine, after treatment, common rail, turbo, everything involved, remember cause and effect. In other words, what you fix a problem like a charge air cooler leak, you're losing boost. We're all doing high pressure smoke testing. And the thing is, if you pretty much find a leak, how did that affect the mass airflow readings? Did that affect your map readings? Did that affect your load indication? Did that affect your common rail injection? And in turn, how does that affect the rest of the after treatment? So it's amazing how a lot of technicians will have these blind sides here where they don't think about, okay, I fixed the problem, but what effect did it have? In other words, if an air filter was restricted, if we got leaks and so on, we got low compression, how does that affect the after treatment? And then vice versa. If we have low compression or we got let's just say restricted exhaust, how does that affect? How hard? Because we've literally have had drivers of fleet vehicles that just drive them to the ground, even though the exhaust is so restricted. So in other words, after the repair is done, and hear me correctly, what was affected and what do I need to address at this point? So therefore, we see codes that are not addressed. In other words, well, it'll go away. It'll do a self-learn. That's probably the biggest BS line that I hear now is, oh, it's got to do a self-learn. It's got to do a learn. It's got to figure it out. No, you need to figure out why, and you need to reset the whatever adaptive parameters there are and get it going again. So very important to keep that in mind. So as we talk about diagnosis, let me change screens here. I'm going to switch up here. And the reason why I'm doing this is because even from the basics, one of the things I used to teach with my 6-liter classes, and yes, I'm going back in time with the 6-liter classes, and we're looking here at the service information here from Ford. And in this case, what you're going to see here, some of the basics of those diagnostics that we see time to time. In other words, we've had 7.3s, 6.0s, 6.4s with actually crank no start. And turns out that, the batteries are low. And what do a lot of techs do? They actually go ahead and put a battery, some jump box or battery boost charger on it. And what happens is that sometimes doesn't do the trick, because if you look right there under data list, you're going to notice it says a diagnostic tool on a 6-liter may reset after 9.5 volts. In other words, if the computer sees that voltage low along with your interface, such as a VCM or any other interface, if it drops under 9.5 volts, guess what? That system is resetting itself and it won't start. So one of the basics of case studies I can tell you that I have seen numerous times has been the fact that all we did was, instead of putting a battery pack or instead of putting a boost charger, because the voltage under cranking was dropping on 9.5 volts, is we just put batteries in. I used to stock Group 65 batteries and we just put them on, and next thing you know, boom, the truck starts. And this was the diagnostic that was performed from other shops In other words, this truck had been to other shops. And turns out that the problem was that everybody was trying to diagnose with the battery pack or a charger on it, and the voltage was just dropping. So basics of what we're trying to teach you here is those basics. I got to pull my notes here. Is that you have to understand that that battery is very important. So if you're trying to get a truck started, whether it's a crank no start or intermittent problem, it's essential that you understand that, hey, the batteries need to be fully charged, need to be proper in good shape. If not, got to put them in. I've seen this with 7.3s, again with 6.0s and other applications where the battery, and again, I'm not kidding. On this case study that I'm trying to get across is that the truck had been to other shops and they couldn't get it started. They couldn't figure out why. And computers were put in, injectors were put in. What was not done on these applications that really made it, an issue. So sometimes a lot of us need to, get back to basics. This is an old diagnostic chart that I actually used to give out. And in this case, some of these basic steps are something that we need to look out for. I mean, this needs updating because the pressure is now 55 PSI, but, it cannot stress enough those basics. And obviously, I've been teaching a lot of webinars, a lot of classes. And this to you, those of you that always attend my training, I appreciate you being here. But, those of you that have not, is that do you have that diagnostic process? That's why even back in the day when I made this sheet, a lot of guys were not performing the preliminary checks. They see that check engine light on, immediately they move on to that, So Ford has always had great in the past, like this 6.0 diagnostic chart, step one, visual inspection, chassis inspection, check engine oil. And a lot of you have heard my stories in the past about something as frivolous as being very low on oil. And today's trucks, and even back in the day, we still had restriction issues. So in this case, we saw issues. And one of the things I talked about before was about turbo learn on a Duramax or on a Power Stroke application. We look at turbo learn and must say yes. And we have seen exhausts that have been restricted, even like an LLY Duramax that I talked about, where we saw that the turbo learn was not going to yes for the simple reason that the exhaust had a restriction, but the truck seemed to run fine. It just didn't have adequate power. It didn't just feel right. But to say that it was a dog, no, it just didn't feel right. And probably the most important thing that we've been discussing a lot on YouTube and everything has been the intake exhaust restrictions. Excuse me, what am I saying? I'm reading sufficient clean fuel. I would say on our shop heydays that at least once a month, we got a truck that would come in on the hook, in other words, from a tow truck, and it would actually be just low on fuel, But another thing we got to keep in mind, as much as we want to condemn pumps, injectors, common rail systems, complete systems, we never seem to look at the fuel itself. And like I've mentioned before in other discussion, even on my YouTube page, is that are we living in an era where it is probably recommended to run some kind of additive to get some life out of these? Yeah. But then, when I teach my Ford training, one of the things you're going to find that Ford pushes on their technicians is that to run the self-test. And like I said before, we can run that self-test several times. So something to keep in mind. But the one thing we need to understand also, and I will be covering some of these case studies as I move along here, is, are you looking at the proper PIDs? What are you looking for PIDs here? So in this case, PIDs means your data lines. Here you could see some that are addressed here on the sheet from Ford, but in this case, you want to take a look at those PIDs that you need to learn. Obviously, this is not a product-specific class, but all I'm trying to say is that, do you know what PIDs are important to look at? So even with 6 liters, a lot of guys don't understand the FICM sync, the V power, the FICM L power, and the V power, how that affects, because we can actually have a relay problem. So obviously, some things that we have to keep in mind and understand and create your own, list of data that you need to look at. So now on the bottom there, you're going to see that low lift pump pressure is a big deal when it comes to even early trucks to newer trucks. We still are doing, when I talk about L5P Duramax, for example, which is the latest Duramax application on the 6.6, is that, we still believe in doing a volume test the way Cummins had taught us in the past. So with that said, let's go back in time though. 2003 GM Duramax 6.6 P0087, low rail pressure, right? It's a common rail, so we check suction under load. Now, this is scary because a lot of you guys are not doing this. It's like, well, then how in the hell are you diagnosing these? So if you know the Duramax, as we understand, as a matter of fact, let me skip a slide here. We understand as we look at today's, early Duramax applications, we understand that from the tank all the way to the injection pump, it was just all a suction. So as we're doing testing here, we need to see, again, no more than 4 inches. So in this case, loaded, we should see 8 to 10 max. In other words, General Motors has changed their specs a little bit, but it's about 8 to 10 inches of maximum. So how many of you are actually checking that suction under a load? Are you driving it and seeing where it goes up to? So that's why that gauge that comes that you can buy from many different vendors nowadays, you're supposed to check, again, what is the total suction there under a load? So you're going to go drive the truck. You see, we look at rail pressure, but most of us look at it at idle. It's in the stall, in the shop, but we never bother to go put it under a loaded test because that's where your issue can be. So again, you also do a total suction test where you pinch the outlet line using crimp pliers. You're going to go ahead and see if it actually sucks enough. So since we're pulling a suction, obviously the transfer pump that's bolted on the back of that CP3 pump, it is sucking that fuel. How well does it suck? So that's why there's a total suction test that General Motors talks about. And in this case, again, you pinch the outlet line of the fuel filter, which is located on the passenger side of the engine. And what you do is you actually disable the FICM if it's an early model, or again, just crank it with the key off using relays or using a jumper. And what you're going to do is you're going to crank it. And at that point, you should get at least minimum of 15 inches, right? So therefore, in this case, we need to do that. So there are other tests. So what I decided to do, just to show you here, is from fuel system diagnosis. This is off the GM service information a lot of you have access to. And in this case, you're going to notice that they're going to tell you to go ahead and prime the system to 10 PSI. So therefore, what you're doing is prime the system at 10 PSI and watch the rate of decay. So it says there, if the fuel pressure drops from 10 PSI to 2 PSI in less than a minute, obviously that is fast. That means you got a bad pump. Not necessarily a bad pump. You actually have a bad cascade valve. Obviously, you've done pressure tests already. You pressurize it and make sure you got no leaks. But in this case, if it drops from 10 to in less than a minute, then more than a minute, then you're okay. It's going to take you to another diagnosis. In other words, we have seen many can't figure out what the problem is because they don't do this pressure drop test to test the cascade valve. So the cascade valve is located on the injection pump. So if it is bad, yeah, you can replace the pump, or if some of you are smart, you can probably get yourself a cascade valve. However, though, this is what's causing the low rail pressure. There you go. Now, please note that when we have low rail pressure, I get it, we can have leaks at the high pressure side of the system. So let me backtrack to this chart. So if the truck comes in with low rail pressures P007 and all those low pressure checks pass, we had under 4 inches at idle, we had under 8 inches under a load. Then in this case, we primed the system. We weren't leaking. We were holding pressure. In other words, not dropping within a minute from 10 PSI. Then at that point, we're going to find out if there's a leak on the high pressure side. So from the old days of LLY, LBZ, LMM2, we had a pressure relief valve on the back of that rail. As you can see where my cursor is at, those were known intermittent leak, especially on the LLYs from my old days. Haven't seen one in a while, but they do happen to do. But I'll be honest with you, I do not actually use a pressure relief valve from Bosch or from anybody. I actually put a plug in there because the system can protect itself from overpressurization on its own. So we use the aftermarket plugs because, again, it wasn't needed in reality. So, but again, note that all these pressure specifications are all there on what you're supposed to be testing there. So shifting gears. 6.0 power stroke. Engine crank does not start. This is an oldie but a goodie. As a matter of fact, I just talked on the phone a few weeks ago to a guy on this one. DTCs are for low ICP pressure. A very common thing on 6 liters. So those of you that have been playing with 6 liters, but those of you that are new to 6 liter, please be aware that we need to have a desired and actual not real pressure, ICP pressure. So you crank it and you find that it doesn't go over 325 psi. The leak check is performed either with nitrogen or with shop air. Personally, I like to use nitrogen, but in this case, we pressure test to see where the leak is at. Now, the diagnosis seems to be at the IPR or the HPOP. In other words, the high pressure oil pump. There is oil pressure, and again, nothing else is going on. So the technician replaces both the IPR and the high pressure oil pump. Okay. Both replaced. Again, we're not going over 325 psi. This system is supposed to be seen around 800, but it's what is desired. So both are replaced, no change, still low ICP voltage. Upon reviewing PIDs, when I came into this first one I ever diagnosed, I checked the ICP sensor voltage and it was biased, meaning that it was hovering in a given voltage, never moved. All I did was disconnect the ICP sensor and went ahead and cranked it and it started. So you're like, huh? Yep. So in this case, we were in a default where it wasn't letting it start. So therefore, like I've said before in previous training, is that you must, when you look at ICP sensors, you look at rail pressures and other sensors, always look at the signal voltage. Okay. So we look at ICP desired, ICP actual, and we look at ICP signal voltage. And it turns out this puppy was at 0. So therefore, again, you actually had a shorted sensor. That was the problem. In other words, a bias shorted sensor. Could it be in the circuit too? Could it be in a connector? Yeah, we've seen that before too. But it was in the sensor itself. So please be aware that as much as everybody thinks they know 6.0s and they say, hey, we see leaks, you're right, we see the O-ring issues and so on. But could it also be a sensor that's actually in the issue? Yes. In other words, it's biased. So with that said, all I'm just trying to say is next time you have this kind of issue, take a look at your ICP sensor voltage on the scan tool PID list, or just real quickly, just disconnect it. And that's what I do. And that's what I've done with 6.0s in the past that I still do to the day. So therefore want to make sure you do that. All right, moving on. Ram Cummins 5.9 liter common rail 05 model. Rolling idle, definitely a rolling idle. In other words, rolling idle means the IPR is going up and down, up and down. It's a very common thing I'm starting to see again on some trucks here locally. Idle is not steady, worse when cold. I mean, it sounds like it's got a tuner in it. It's just romping along the engine. So it is a good idea to always check the lift pump volume, make sure we're consistent. I have used this from the old specs from Bosch, which states that 1 liter in 30 seconds. And I use it across the board for everything. In other words, I want to see that I do get that volume of fuel before I start condemning what's going on with the rest of the fuel system. Now, we check the FCA duty cycle. What is the FCA? That is the regulator or MPROP, as they call it from Bosch, that's located on the injection pump, the guy that controls your rail pressure. So in this case, we should see somewhere around 30 to 34, 35% of duty cycle, but it's actually fluctuating, not steady, at 29 to 31. So next time you play with a Ram Cummins, it is a good idea for you to look at that duty cycle, see where it's hovering. Duramax is the same thing too on the pre-2010 models. So therefore, you can look at the duty cycle. So you check the set point and actual rail pressure, and it's varying quite a lot. So as you hear that idle just rolling, just take a look at your set point or your actual your desired rail pressure and your actual, and you're going to see it change quite a bit. So what was the problem? Well, the problem was the FCA. And in this case, that was supposed to say MPROP, not HPOP. My autocorrect must have changed it. But in this case, it's the MPROP, not HPOP. So in this case, it was the MPROP FCA that was the issue that's sticking. We had so many rolling idles that if you open one of my tool drawers, guess what I have in my tool drawers? I have a spare, MPROP or FCA sitting there that I just bolt on because they're very easy to access for the most part on these 5.9 liter Cummins. So therefore, rolling idles. And this will pretty much work on any common rail, whether it being a Sprinter, whether it being a Cummins 5.9, a 6.7, and even a Duramax, like I said, with the CP3s. Those have been known to cause rolling idles in the past. So So therefore, be aware of that. Those people that drive the manual transmission trucks will be complaining about it more than the automatic guys. But in this case, it could be anybody really, but that could also cause it too. So you can understand, because I'll be talking about this a little bit later again on a Duramax application. Those of you that don't know this or have any training, that FCRM prop is located on that injection pump. And if you look really closely, you're going to notice all fuel volume, and hear me correctly, all fuel volume that goes to the fuel rails must go past this regulator on the injection pump. So therefore, if you notice on the top of each one, you're going to see that it's fully open and in other words, it's fully open normally at rest. In other words, it's an NO valve. In other words, it's normally open. So that would mean that if you disconnect it, you go to full rail pressure. And if you connect it, it'll be regulated. So it is not recommended for you to disconnect unless you're doing some testing, but you really don't want to overpressurize the system, because it will if you give it RPM. So with that said, please note that the computer must energize it to close. So when we talk about that duty cycle around 30%, if you had a high return, you actually would see that duty cycle drop to like 15 to 20%. So another tip, since we're on this truck, is that if you see that duty cycle very low, it's trying to compensate for a leak in the high pressure system. So therefore, something to keep in mind. Now, to the day, we still recommend that if you are working on a 5.9 liter Cummins, or if you're working on a 6.7 Cummins, it is a good idea to remove it, and that'll tell you the change or the state of the fuel cleanliness that's inside of that injection pump. In other words, we remove it and we can inspect it, not necessarily for metal debris like a lot of you are used with the new systems. No, we actually were looking for contamination, and it's scary what can come out of there when it comes to contamination. So you're cooking real good. Shifting gears again. This is an oldie, but I still should mention because it still happens. This is what I was talking about at the beginning of having a diagnostic process, because this truck came in, and this one will stand out forever in my mind because, yes, you can see that the air filter is completely dirty. It does not go over 10 miles an hour. But again, we uncorked the exhaust, and it actually ran a lot better because this is cause and effect. In other words, the air filter was totally clogged. She was breathing very little air, so it was a fuel-rich exhaust. That in turn clogged the DPF. So obviously, uncorking the exhaust, this thing actually was running. However, though, it was pretty interesting. Some of you have never seen this. This is an oldie but a goodie, like I said. But in this case, I never had seen a truck do this, as you'll see on the display. Is want you to stop safely now. That's how bad it was. And I've never seen another truck ever do that. This has been a one-timer. So if you've seen that, well, good to you. But in this case, this was really fun. I've never seen a truck actually say to stop safely now. That was pretty funny. But here's the deal, though. Like I've explained to some, but I'll explain it again. Again, those of you that are new haven't seen this. Some of you haven't. When you look at the diagnostic trouble codes that were set on this truck, now, please note as I continue here, this is why some guys, I just don't understand why they don't catch these issues. And what do I mean by that? Is you're going to see an air filtration code set. In other words, the filter is restricted. That was the main cause. That in turn caused the exhaust to become soot loaded. It got so restricted, it couldn't actually have any exhaust coming out of it. But these are the cause and effects. In other words, what actually caused these codes to set. So as we're looking at this, you're going to see the fuel rail pressure sensor low input. Why? Let me pause it here for a second. Why would the fuel rail pressure code be set? We didn't have a fuel rail pressure problem per se. Well, the engine was lugging so badly, barely running, because A, it couldn't breathe, and B, it couldn't fart because the DPF was just so loaded. So the engine was lugging so slow that in turn, it's so slow that the injection pump was turning too slow. And that caused the fuel rail pressure code to set. So there you go. But you're going to see as I go down the list here, you got cylinder 1 contribution, cylinder 6, you got turbocharger under boost. In other words, these were all caused by, again, the air filter and the after treatment system being so plugged up. So obviously it got hot. as you can see there. So we need to figure out what actually happened. So in your thoughts as a technician, how well is this engine breathing? How well is it farting? In other words, how well is it exhausting? That's why those of you that are new and those of you that don't remember, in today's society with after treatment, and after treatment has been around for a lot of years now. And if you're dealing, let's say, with a 2010 truck, a 2009 truck, 12 truck, whatever it is, and it's got over 200,000 miles, hell, over 150,000 miles, you have to ask yourself, what is the condition of that exhaust? So therefore, the after treatment could give you issues, could give you numerous codes, but wouldn't it be a good idea for me to go ahead and uncork that exhaust? So it's religion with me, because I'm like, okay, I see this problem with the engine. I see this problem with the after treatment. Maybe it's a good idea for me to take a look at that exhaust. So therefore, there's a flange on that downpipe, which we uncork over and over again. And we're looking again for any leaks there. So not leaks, excuse me. We're looking for different colors of smoke. So therefore, what is that smoke color? In other words, are we getting black smoke? Are we getting oil? Are we getting coolant? What is coming out of there? So that's what we're looking at. All righty. Okay. Switching gears again. 2009 Ford Power Stroke 6.4. Engine runs, stalls at times, sets code for high rail pressure. Now, you suspect the fuel rail pressure sensor and you check the sensor voltage, it's okay. You perform that debris check that Ford was telling you, where you disconnect the line off of one injector and crank it over, and let's see if we got metal coming out. And we do have metal coming out. It needs a new fuel system. Well, here's the deal. The truck is running. First clue there is the truck is running. So I'm like, okay, that means the pump is generating rail pressure. And again, it's got high rail pressure. So that means we're really pumping pressure, but it's not regulated at times, right? And there is metal in the system. So I'm like, okay, in some cases when I've had this issue, and I've had it many times on 6.4s, I'm like, okay, we can help the customer if he needs help. So the customer looks at me and says, hey, listen, I can't afford a whole new fuel system. Is there anything you can do? Because this truck is my livelihood. So me being nice, I go, okay, but you got some money? Yeah, you got to ask them if they got some money. They do. So in this case, all right, here's what we do. Well, first of all, when we look at the high pressure injection Siemens pump that is used on the 6.4, as we look on the side here, you're going to notice that this, I call it an annulus pump here. And this annulus pump, again, is like a transfer pump pressurizing towards the volume control valve, as you can see there. Hopefully you can see my cursor. So in this case, that volume control valve controls the volume of fuel going to each plunger. So therefore, that's controlling the rail pressure. However, though, we need to ask ourselves, where did that metal come from? So again, if you haven't done that metal cap test, as you can see right there, this is what was discharged out of one injector line. So when you do this test, you're sacrificing a line because those lines are not reusable. All right. So, and I usually do, what is it, 1, 3? It's either 3 or 5 that I do on the passenger side, because that's the easier side to get to. All right. So we got metal. But I know that the source of metal is usually from this annulus pump right here. And what it is that it's actually scraping along here. So it actually just eats away at this housing. All right. And let me show you a better picture of it so you can see it right there. So here you can see the housing of this pump that's been taken apart, and you can see how it actually just swipes in there. So what it literally does, it just eats away at all this. But this is just a transfer pump. You still have the lift pump pushing fuel through. So what we have done is that we go down to the truck underneath the cab where the HFCM is. In other words, where the primary fuel filter is, and the fuel pump is at, lift pump is at. And what we do is we put this adapter. They have these cleaners. We use the one from BG, and where you run a filter, you really run a filter, and you run a fuel cleaner mixed with diesel fuel. So now the truck's running off of this container. So if you want more information about it, send me a message and I'll get it to you. Well, what we do is we flush the system, and that's what it is. It's a fuel flush system. So as the return's coming back, we're capturing it on the container, it is filtering it, and it's actually taking the cleaner. So we literally are flushing the system out. Obviously, the primary fuel filter and the secondary fuel filter need to be changed, but we're trying to capture all that metal, because once this is scraped away and actually clean this all off, there's no more. It may not be doing transfer any fuel, but it's already done its job. It's sent metal in the system. We're flushing it out. So at that point, once we flush it out, we could see the debris of metal that we collected on the filter on this adapter we're using on this fuel flush system. And what we do is at that point is we put it all back together and fire up the truck, prime it, obviously. And then what we do is we see what's going on. Sometimes I will get a truck that'll actually have like 1 or 2 injectors that are not working well. The fuel trims are away. So I'm selling the customer the flush and 2 injectors. And next thing you know, they're on their way out. It's running fine. So I guess what I'm trying to say is, just because this annulus pump has gone bad does not mean if it's still pressurized and you still got high real pressure and it's not regulating, it's because we got contamination in it. So by us flushing the system, we are able to restore the system to function and work. And guess what? I've done some of these, and these trucks are still got over 100,000 miles after we cleaned them up. Remarkable. But in this case, it's just another way of helping out the customer and us making a little money, all by flushing it. Now, I know what you're thinking. Can we do this on CP4s? No. Okay. Once those are mega contaminated, no, you can't do that. But this has worked very well on these 6.4 Siemens pumps, where these are worn out and they scrape metal through the system. But you got to always remember what caused this. What caused this initially was that there was contamination, poor filtration. I take that back, not poor filtration. Yes, technically poor filtration, but it was just the fact that filters were never maintained, never replaced. So therefore, that's what we saw going on there. All right, very good. Switching gears again. This is an oldie too. This is another one I've taught before, but actually I've had a few guys I've called and helped them out with it. This truck came in with initially an overdrive and TCC is just shifting and kind of a fishbite effect deal going on. And we did find that there was a broken TV cable. That was all replaced and adjusted properly. And those are the old timers that were pretty easy to do. So we replaced the cable, got it all adjusted, but the vehicle came back with an issue. But again, it was more prevalent. And when we talk about a fishbite effect, it's like, fish bite off a fishing line where it's just biting at you. You feel like this jerking action. Well, no coats were set, obviously, and we couldn't see what was going on. However, though, what stood out is that, okay, I have the old Cummins adapter that goes on these VP44 pumps. That adapter that Cummins sells that actually lets you idle the truck and raise the idles to actually separate the pump from the rest of the ECU system. And if you don't have one, I'll get you the info. And I don't even know if they sell them anymore, but I got mine. It's one of my special tools that I have in my toolbox. But it didn't jerk or do anything when I had it running on that adapter. So it kind of questioned, okay, do I have a bad VP pump? So experience has taught me that before I condemn a VP pump, I always do a voltage drop test. Well, guess what? 13.5 at the battery. We had like 12 something at the pump, if I remember correctly. So what was the problem? Well, I'll tell you the answer. The answer was a bad ground. And those of you that work enough with these VPs know the fact that as you go down on these 24 valves on that connector, you're going to see that we have bad grounding. So as we look at the wiring diagram, you're going to notice there's a shared ground right there. So in this case, we literally go from battery power all the way to ground. We do a voltage drop test, and that's how we found out we had a bad ground. So what did we just simply do is we just tapped into that wire and just sent it to a known good ground, and that actually fixed the problem. So I guess what I'm trying to say is that you may want to do voltage drop test between power and your ground. So again, there's your input number 7 and there's your ground, and you're going to go from 6 to 7 and you're going to do a voltage drop test across it. Got to get creative with the connector to do it, but that does help. And that's what you're going to find. So in this case, that takes care of the issue. And I can't tell you from experience how many VP pumps have been misdiagnosed because of this bad ground. So therefore, that's why we preach about doing a voltage drop test. Literally back probe at 7 and 6 and going ahead and measuring the voltage across it again on that connector going to the pump, as you can see there. So definitely want to do that. Also a sidebar, if you ever do a VP44 pump, would it be a good idea for you to replace, again, wouldn't it be a good idea for you to replace the relay that supplies power to that VP pump? So very important thing to do. So there you go. Switching gears again. I'm just moving along here. 2012 ran Cummins 67. Truck comes in for check engine light on. It has codes for soot accumulation. Now, in this case, you find there's a regenerate and even has the code that allows you to do the regeneration. And in this case, you need to ask yourself, why did the truck come in with a soot accumulation when it's supposed to be cleaning himself? Why isn't he doing his own regenerations? Is it drive style? Is it idling a lot? Okay, maybe. But in this case, this is now becoming something that I'm starting to see more. It's happened to me twice. So what happened? I run a regeneration. After 5 to 10 minutes, I find that it kicks out of the regeneration. How do I know it kicked out? The idle speed dropped, because usually when we run a regeneration, the RPM elevates. Okay. But it kicked out. So I'm asking myself why, so the computer kicked it out. In other words, the onboard computer kicked it out. Something happened. So obviously we're going to look at EGTs, exhaust gas temperatures. So as we're sitting, the truck's running there. And as I'm running it, it just kicked out the regen after 5 to 10 minutes. It just did it, no more than 10 minutes. So now it's idling. So here's the deal. The EGTs are actually climbing, So the question is, what is too high or too low? So let's review before we answer this. So I'm going to use an old slide here. This is an old LB7, but it makes the point here. As we look at an old, not LB7, excuse me, LMM. This is a 2007 to 2010 truck. You're going to notice they had a separate DOC and a separate DPF there. Okay. Now we have a sensor before and after. So if we're going to bombard the exhaust with post injections and get that DOC nice and hot to burn the soot in the DPF, we're going to start some cooking. So let's take a look here. There is a pre and post sensor. Okay. Don't worry about the differential pressure right now. We're going to look at temperatures right now. So temperature will be higher after DPF if there is soot or related material that will burn. Hear what I said. If there is soot or related material that will burn. So is it fair to say that the DOC is creating the heat? And at that point, that's going to start a burning or a fire, if you want to say it that way. You're burning something in the DPF. So there you go. So when we look at temperatures, here you can see this old slide that I still use to the day to explain this, is that we need to understand, obviously, that we are creating an exothermic reaction in the DOC with fuel to create that regeneration event. So here's the deal. What's the minimum temperature you're supposed to see on any truck when you're looking at the regeneration event? Well, you're supposed to see a minimum of 980 degrees. I round it up to 1,000 degrees. Okay, that's the minimum. Okay. Now, here's the thing that nobody talks about. What is the maximum? Now, we're looking at EGT 1 and 2 here. We're going to come back to this guy. Take a look right there. What is the inlet temperature and what is the outlet temperature? So is it cooler after the DPF? Because these EGTs, like I said before, are before and after that DPF. So this canister right here, that's your DPF on this early model. But it makes the point here because we're putting a sensor before and after. So that means when we look at today's after treatment, like 2015 or later, they're all welded together. However, though, we still have sensors in between them to look at the inlet versus the outlet temperature of that diesel particulate filter. Now, here's an oldie here. Here is one I was doing on I think it was an LMM truck too. And in this case, you're going to see the temperature starting out at 11, 12 degrees. Look at the outlet temperature, 1227. Is the temperature after DPF greater here? Yes, it is. As we continue with the regeneration, 1139, the temperature after is 1270. So it is higher. Moving to the next one. Here we can see once again, we see that the temperature is greater after that DPF. And as we look at the last slide right here, we're going to see the temperature is 1234 degrees. So we understand, those of us that have done enough regeneration on the big three, we know that Duramax seems to be the most aggressive when it comes to the temps. In other words, it's not surprising to see 1278 to 1300 degrees. So the question begs, what is too hot? Well, we pretty much have come to the conclusion it's about 1350. Okay. 1350 to 1400. After that, you better start puckering up. That means you're getting too hot. Let's come back to the original problem. So we're looking at this truck, back to the 2012 Ram, using that information from that Duramax that we just saw. Should the temperature be warmer after the DPF as you're cooking it? You're burning it, yes. Now, by the way, let me come back to here for a second. Are we burning anything here? The answer is no, because the temperature is cooler. So nothing's happening. In other words, there's nothing to burn. Y'all see that? Because it's cooler. Hopefully we're not losing you. All right. So therefore, going back to this Ram, knowing what we just saw in the Duramax, we are actually have, the EGT's climbing. So it's climbing. Now, mind you, it tried to run a regeneration. It kicked it out. It's still running. And I'm watching the EGT after the DPF just climb, and climb. So it's climbing. Did I say climbing enough? In other words, it's going over 1400 degrees, 1425, 1450. You talk about feeling helpless. I call this DPF runaway. This is my own thing, because something is burning so hot in that DPF that it's actually just going sky hot, which tells me something is there that is not supposed to be there, that's actually very flammable. Some type of additive, some type of crap they put in there. So therefore, it's very hot. So we need to have a conversation with the customer after this happens, because what the hell are you pouring in that fuel that's actually, again, affecting the DPF that is just burning hot? So by this point at 1450, I have my crew around the truck with fire extinguishers, but it's inside the DPF. We can't do nothing about it. To the point finally around 1500 degrees, it blew out the pressure differential tube, and then it started cooling down. Well, obviously the next day we had to let that truck park it. We parked it. Next day we'll get to it. We pulled it apart, and everything was melted on that DPF. It had gotten so hot, melted to the core. So the thing is, what was in there? Well, it was poisoned. And what do I mean by poison? Oil-based products. We got a lot of wing nuts that like to use transmission fluid, some type of two-stroke oil. Something was in there that wasn't supposed to be there, that was very flammable. And that's why we're seeing so far in my career, I've seen 2 DPF runaways, because people are pouring something into mostly the fuel, but it could be in the engine oil. But in this case, it's actually very flammable and just permeates itself, that once a regeneration is started, it's just going to take off and get so hot because it's burning and literally destroys the diesel particulate filter. So after having a conversation with the customer, guess what he was doing? He was running 2-stroke oil. Yeah, I know. But I get a lot of customers around here that run 2-stroke oil and Jet A or Jet B fuel. So that was a problem there. So again, maybe it's a diesel truck. Maybe we ought to be using diesel fuel. Hello. So therefore, just note that was the cause here. So there you go. So therefore, watch out for those DPF runners. But if you want to know how well, if your scan tool does display during a regeneration, your EGT temperatures, take a look at that temperature after the DPF to make sure it is warmer, telling you it's burning. And if it isn't, that means there's no burning at all taking place. So pretty cool. Learning. All right, next one. 2012 GM Duramax 6.6 Silverado. Check engine and SCR light is on. It's threatening to derate. It's telling you so many miles. DTCs are set for NOx sensor 2, high concentration. So yeah, we are seeing high. In other words, the NOx sensor 2 levels are higher than what NOx sensor 1 is. You text the NOx levels, and yeah, they are high. We're looking for a NOx level. So what are we looking for? Well, we generally want to see at idle no more than 300 parts per million on NOx sensor 1, and obviously lower than that on NOx sensor 2, to the point it could go to 0 almost. So this is under idle speeds, right? But the thing is, there's no other codes except NOx concentration is high. So typically, most technicians that know these somewhat, they're going to run an exhaust fluid quality test. This is what it will take for it to check for NOx levels, and it does not clear. In other words, it doesn't pass. Now, please make a note, and I'm not teaching the Duramax, but I taught it before, where when you run exhaust fluid quality test, it's going to say on the screen of your scan tool, test in progress, test in progress, test in progress. But if it don't clear after 15 to 30 minutes, kick it out, because that means that ain't going to pass. So we definitely have an issue here. Now, the problem is every time I talk to techs, I know it sucks to do, but you got to do it. And in this case, your diagnosis includes checking reductant and injector spray and volume. Okay. A lot of guys don't want to do that, but you have to. And I see these guys running the reductant fluid quality test and running the fluid quality test and la, but they never check the reductant injector spray and volume. So what do you see here? This is an oldie too. I've had other ones. I should have brought some other pictures, but there you can see the one on the left versus the new one on the right. All right. Soot accumulation. So in other words, it had hardly any volume coming out. So therefore, you got to understand that as much as you dislike the after treatment, if you want to know why it's not reducing NOx, it needs that DEF fluid to be injected. So again, you're going to run the reductant fluid quality, but that don't tell you if you're spraying. So therefore, the only way to know for sure is to perform the published diagnostics of running a spray test and a volume test, and then you're going to take that sample of DEF fluid and you're going to test the DEF fluid. So time and time again, when I get phone calls on this, I can't believe how many guys will not do the spray and volume test. Yes, I know some of them are not easy to get to. I get it. And a lot of you don't have a graduated cylinder. And what is a graduated cylinder? That's actually a test, tells you how many milliliters. Personally, get on Amazon.com or do a YouTube search on graduate cylinder, get yourself a nice, and buy the glass ones. The plastic ones will get faded and suck. Get the glass ones, okay? And those will help you measure the volume and see the spray correctly of what streams you're supposed to be seeing, because it's not supposed to shoot the fluid, it's supposed to spray the fluid. Because if you understand how DEF fluid works, once it's injected, the chemical reaction immediately with the heat in the exhaust changes it into ammonia. And it is the ammonia that breaks up the NOx. Hopefully you give that heed there. So again, I don't care what diesel application that has, SCR, you need to be doing those tests. All right. Short and sweet to the point. Next one. Got a few more left. Engine runs but loses power under load. It sets low fuel rail pressure. Well, that seems like one we already talked about. Yeah, it is. But, we need to talk about how it works on the Cummins. So we saw this on the Duramax earlier. You test the lift pump pressure and volume. Again, 1 liter in 30 seconds. We see we got low lift pump pressure and volume. You find no issue. You leak check all the common rail, no leaks, even from the pressure relief valve. Now, I found info a long time ago from Bosch that there is a return volume test on the pump. So if we look at this old chart here, or old graphics, let's take a look at this. If we understand an old common rail here, this is an old 5.9. And when I say old, 0304. And in this case, you're going to see that we have our, actually, I'm going to use my pin here for a second. You're going to find out that this is the outlet line of your CP3 pump. And it goes to the rail. Big deal, right? And you got a pressure relief valve here. This is your pressure relief, relieving the pressure back to the return, right? However, what Bosch is recommending is you do a return volume test on the pump. So here's the line coming out. This is the return. So, oops, this one right here. God dang it. Sorry. Let me do this again. Erase, please. Hello. You're not listening. Thank you. There you go. All right. Let me try this again. This is the high pressure line. That's in dark. And then you're going to see your pressure supply. Again, that's in gray color. And then you're going to see the white line. And that is your return. What Bosch is saying is that they want you to do a volume test on the return. So there's your cascade valve, but we'll get to that there in a second. Let me show you this diagram. What the Bosch says, and this is actually a old Bosch chart, and what they literally want you to do is they want you to do a pump return flow test. And what it is right here is they want you to do a volume test. And in this case, you got no more. The spec is 1,000 milliliters per minute. That would equate to 1 liter in 1 minute. So that will tell you if it's returning too much. Okay. So therefore, what is the cause? This guy right there. That's the cascade valve, which we talked about on Duramax, but you don't have a plunger on these Cummins. So what they want you to do to test the cascade valve, see if it's not causing your low rail pressure codes because you're returning too much of it, is you test that cascade valve. So there's the one on the CP3 early model, and here you can see one on the 6.7 Cummins here, and you could see that there's your cascade valve there too as well. So again, what we are trying to get across once again is we're trying to find out what caused the low rail pressure code. That means that cascade valve was stuck open and it was returning too much fuel to the return, thus not giving enough fuel volume to create that rail pressure, thus setting the P0087 code. So therefore, we need to keep that in mind. Very important. Now, please note a few key items here. When we look at this fuel system here, let me get rid of my cursor. When we talk about Cummins common rail, right? You need to understand that there's many places for leakage on these. These are prone to leaks. Number one is, it could be the injector. So let's go to the injector first. So if you've never had a class on this common rail system, we all know about the pressure differential on this nozzle where we have the same pressure above and at the bottom, and we could see that this ball controls the leakage above the nozzle, and that in turn causes nozzle lift and inject. The point I'm trying to make is that, this ball and seat has been known to be still to the day to be an issue. So that means we would have a high return. So what I like to do on these applications is I like to do a leak down test. And what I've done in the past is we actually use nitrogen or shop air to do a leak down test on this system. I don't do return flow tests because you got to use all the adapters and all that, and it's not always conclusive. To isolate who's the leaker is not easy. So that could be a problem. But another key issue we see is the mating of that tube and that injector that could be the cause. So with that said, please note a few tests. I'm going too much at a time. Let me first start with the basic one. The easiest test that we've been teaching for years to know if you have excessive wear on that ball and seat is to do the snap throttle test. But it only works on 5.9s. It doesn't work on 6.7s for some odd reason. I think it's the injectors. But in this case, what we want you to do, snap the throttle. You snap the throttle and the RPM will go up and then go down, right? And come back down. All right. If the RPM hovers up and takes forever to go back down, you like that? Goes up and then it takes forever to go back down. Classic ball and seat. We've been teaching it for years. That means that ball and seat is worn, is struggling to seal. And the reason why the RPM stays high, then finally it slowly drops, is because it's keeping that nozzle open longer, which in turn will cause the RPM to stay high. So that's what we call the snap throttle test, but only on 5.9 common rails from 03 to 07, early 07. So in this case, that's a great test that helped us know if we have a wear and tear on the ball and seat there. So works very well. So I like to do leak down tests. Now, I'll be honest with you, in my travels and teaching classes, it's amazing what you learn from these old timers. I like to work with the old timers. I was driving through northern Oklahoma and I stopped by a shop, and this man apparently knew me through the videos. And he said, I've seen your videos, and very nice guy. And I said, okay, you haven't been on any training. How is it that you're diagnosing these common rails? Well, he took the old banjo fitting from another engine and actually cut it off. And what he does is he puts this tube, obviously he disconnects it, and he puts it to a bottled water, like a bottled water, and I said, why are you doing that? He says, well, he disconnects the inlet line going to the rail, and he actually takes an air nozzle with the rubber tip on the end, and he literally pressurizes that rail. Obviously the engine's off. And what he does is, once he pressurizes with air, He looks at that return coming out of the back of that head where he put his own adapter on. And what's he do? He checks to see if there's bubbles coming out. So if the bottle has bubbles in it, right, that means that he's got a leaky system. Something's leaking. And now he could isolate by using caps to actually figure out what's going on, where the leak is at by isolating. The moral of the story is that he come up with his own way to find to see if he's where he's his leaker at, and that works for him. So therefore, that's pretty cool. But I told him, hey, you can't test the cascade valve unless you do a return test, which again was 1 liter in 1 minute that we talked about there. So, and here you could see other specs for other stuff that Bosch recommends. You'll notice that even for lip pump, they're saying 400 milliliters in 10 seconds. Well, 20 seconds would be 800 milliliters. So we have another 10 seconds that we need. That'll take us just shy of a liter. That's where I get that liter in 30 seconds that we like to see. So definitely make it a habit to test, or else you're going to be in trouble. Very important to do that. Okay, classic stuff. So a quick note, when you look at that transfer tube and that injector mating there, when I was teaching my hands-on diesel master course, one of the things I made my guys do in the class was actually install a tube and injector. In other words, installation, you replace injectors. And would you believe only one guy from all my classes I taught, there were many, got it right. In other words, we leak checked it to see if it is. So that kind of told us a lot of techs were not installing correctly these tubes with the injector. So please follow the procedures outlined. You're supposed to install the injector, put the hold down bolts, but don't torque them down. Then you install the tube and you line up the tube with the injector. Then you torque the injector, then you torque the tube to make sure it's in. Because I can't tell you that mating between that injector and that tube have been so many times missed. And when we take the tubes out, we can see how it was, it's not conical in shape. It's all just worn to heck because it was installed wrong. A lot of damage. So can't say that enough about these Cummins applications from the old to the new. All right. So make sure you put those correctly, follow the procedure. And last but not least, will you please torque those hold down? I know they don't take a lot of torque, but you torque them down to specification along with the tube itself as well. Okay. Thought I mentioned that. Moving on. 2012 Ram 6.7. Truck has no power. Idle's fine, but no boost. Very common one that I get. No bi-direction control, so you can't control the vanes on this. Sorry, you can't do that. And sure enough, I went for a short test drive, and it was a short test drive. Yeah, we had no power. This thing had no power at all. I know what you're thinking. Exhaust restricted, right? Well, maybe, but you check for codes, and in my experience, sometimes, not all times, I've had an EPS code. What's EPS? Exhaust pressure sensor. All you got to do is simply disconnect the sensor. So at that point, if power is restored, in other words, to start boosting, everything is great, you got an EPS issue. Not necessarily the sensor, though. It could be, or in the circuit, but you also want to check the passage with the sensor removed. So the fix was maybe a sensor, but on this picture I got right here, here's the sensor right here. It's right there. Sorry, I couldn't get a better image, but that sensor you just disconnect it. It should boost. So in other words, can the turbo still function with that sensor disconnected? The answer is yes. So what happened was that sure enough, we had a bad sensor, but upon removing the sensor, that passage was so clogged, and good luck trying to clean it. In other words, there's a tube that goes to a U-turn, L-turn, goes up to the sensor, and it was totally blocked. So there you see us literally chipping away at the carbon to try to get it loose. And so it had two problems in essence, a bad sensor and the passage was full of carbon. Those of you that worked on this probably know about this or dealt with this before too. So there you go. All right. Thought I'd throw that one at you. All right. 2008 Ram Cummins 2500. Another no power. DTCs are for suit accumulation. You run the regeneration, find no change in the suit counter. You check the inlet and you find an issue. In other words, what did we find? This is what we call the carbon wall. I hope it comes clear for you because this is taken by an actual truck. I have quite a whole bunch of them. This is the best one I got, so I keep using it. But let me zoom this up if that helps. You can see that the texture, hopefully it's coming clear for you, but if not, just trust me on it. It looks like a cloth. This is carbon accumulation on the inlet of the DOC. So as we uncork the exhaust, stuck the camera towards the DOC inlet, and this is what you see. So if you understand carbon, carbon loves fuel. So as those post injections were sending fuel down the exhaust to the DLC, this was absorbing it. So for carbon to condense itself on the inlet of the DLC tells you how cold this exhaust is running. It is potato chip thin, but all I'm saying is that it can actually become more and more. So as more regenerations were coming along, it's actually getting thicker and in turn creating more restriction in the exhaust. So therefore, we had to clean it. Obviously, the right thing to do was to remove the whole after treatment, send it out to clean. But we got a little creative with carb cleaner, but I didn't tell you that. So then after we fired up, we just ran holy bejesus out of it to get this nice and hot. But it kind of begged the question, why was it running so cold that we had this? And what's funny is that, even from the RAM service information, they actually have a lot of pictures of you to inspect that DOC too. So therefore, please keep that in mind. So if you have no change going on there, yeah, definitely something to look at. Switching gears again. And oh wait, now this one sticks. This is an oldie, but it hurts because things got ugly with the customer on this one. Truck comes in. Gee, is that a red flag? You see something that you're not supposed to see? The tuner. Truck has been deleted. All right. The issue is it says all of a sudden it starts running really bad, real low, but it ran pretty good for us. But we checked the basics. Once again, we see lift pump pressure, and it's almost at zero. I mean, we barely got any lift pump pressure. So we're like, hey, we don't got enough lift pump pressure, and obviously the volume was low. Sorry, got to keep my throat lubricated here. But lift pump pressure is low. Here's the deal. It was not the pump the problem. The pump was on these 6.4s. The fuel pressure regulator is located on inside of the secondary fuel filter right there behind that gauge. Secondary. You can't replace just the regulator. You have to buy the whole housing. And we did. We replaced the whole housing. Put it in, fired it up, and obviously, and before I should say, though, I should tell you this. Let me mute this. You're going to notice, I'm going to fast forward to get through this here rather quickly, but we did a fuel pressure test. And as we're doing the fuel pressure test, you're going to notice it's commanding the various stages of fuel pressure. Again, this is before the regulator, mind you. And in this case, you can see the rail pressure was not holding when it did its next test here, stage 4, I think it was. We're watching the screen. See what it climbs to. Boom. There you go. So therefore, it was only getting 16,000. That's all we were getting. So obviously, it failed the test on this scan tool. And it told me it was a problem. So obviously, replaced the regulator. That solved the issues. However, we looked at fuel trims. And as we're looking at the fuel trims here, I'll zoom it up here in a second if you can't see it. But we had, I believe it was 2 injectors that stood out. There you go. Look at number 6 and number 7. They're both positive. We don't like to see no more than at least 3%, but in this case, we're seeing 11 on both of them. That means we're commanding a lot more fuel. It's supposed to be close to zero. So if it's positive value, it is commanding mega fuel for those 2 injectors. So obviously we had 2 injectors that needed help. We did do a relative compression test to make sure that the cylinders were okay. That was not the issue. Compression was okay. So obviously we needed an injector. So we told the customer, hey, you need the regulator, you need 2 injectors, but it runs. He didn't have the money for the injectors. So here we're showing the scan data before and after of the pressure. Just take my word for it, our pressure was okay. However, though, the customer we test drove the truck. I test drove it. My lead tech test drove it. It ran great. It just, like I said, those injectors were just adjusting fuel. So we definitely were going to need, injectors in the future. We told him that. So he pays for the regulator. We did a regeneration on it, picks it up, calls me That late evening, we were still at the shop, saying that the truck started dogging and ran bad. I said, you know what? I don't know what happened, but we'll go pick up the truck. We're trying to be good, taking care of the customer. Again, he said it was running bad. So he says, don't worry about it. I'll leave it at the shop. I'll hide the keys. Come get it in the morning. Don't worry about it. He was nice. I said, okay. The next morning, we run out there. It's almost 40 miles to go get the truck, and more than we had test driven it. And picked it up. And sure enough, it ran fine when we started. Came back. And less than a mile from the shop, it acted up real bad. Now, mind you, what I'm about to show you, we did this test prior in the diagnostic, because one of the things we like to do is we always check on 6.4s, knowing how they dilute the oil. We always check the outlet pressure coming out and what's coming out. And what do you see right there? We had engine oil. So therefore, we did do this test. I never had seen this before. We did do this test to see if there's any oil spitting out when we first did our initial diagnosis. And guess what? There was no oil. And then all of a sudden, once it runs for a long time, those turbos were playing tricks on us that they were leaking oil, as you can see there. So we told the customer, listen, I don't know how we missed the diagnosis, but tell you what, we'll sell you the turbos, but we'll eat the labor on it, which was a lot of labor to eat. But I want to take care of the customer. He got pissed off. He said, all right, and his wife was even worse. Got not to be sexist, but oh, she was worse. He picked up the truck, took it to a Ford dealer. Guess what Ford said? You need a motor. The joys of having this shop. There you go. Moving on. 2013 Chevy Silverado LML. Truck comes in with codes related to accumulation. Brake switch input also code set. Will not run a regeneration. So therefore, those of you that work with GMs know that GMs are notorious for brake switch issues on the, I don't know about the L5Ps, but I see it a lot of LML and earlier. Will not run a regen because the brake switch has a fault. Now, please note, the brake lights did work. So if you know these switches have, it's like a 2-in-1 switch. One is an input to the computer and one is for the lights. So therefore, we definitely had a brake switch issue, which was inhibiting, again, the regeneration to happen, because if it saw the brakes applied, it will not run a regeneration. So what was the fix? Replace the brake switch. And guess what? After running, pressure differential was under 1 PSI, which we don't want over 3. It was under 1 PSI, and it worked great. So a lot of techs will underestimate the brake switch. They will clearly see the brake switch code, but they don't think that's their issue with the regeneration. They start doing other stuff, reprogramming, blah, blah, blah. When please note, if the computer thinks that the brakes are applied because of the defective switch, then therefore you definitely have a problem. Now, what's nice about the scan data on these LMLs, you can see that brake switch input. You clearly can see it. So therefore, that'll help you with your diagnosis there so you can know what's going on. So therefore, don't underestimate the power of the brake switch on any application, especially on these GMs. All right. And last but not least, I just did a presentation a week ago, and I was talking about how I get so flustered on when shops tell me that, I just talked to a shop owner actually last week. We just set up more training with him, and he was complaining to me how, his shop did 120,000 last week, he says, but I had 10,000 in comebacks. So subtract 10,000. So that's a 10,000 is a hit. And when I hear from shop owners that a lot of it has to do with the fact that it's charging and starting systems, I'm like, Jesus Christ, you guys don't know how to test a starter or a generator, really? Voltage drop testing. And on a 6.7 power stroke, y'all see that yellow wire right there? That is notorious to cause that battery light to come on a dash and cause charging system issues. And I've had shops that literally say, yeah, we put in our third alternator and it still doesn't charge. Gee, what made you stop at the third alternator? You should have kept going, buddy. No, we need to understand that these inputs that are going here can cause no charging conditions, So therefore, a very common, easy thing we see on the Ford Power Stroke 6.7s is that we can have an open between the PCM right here and the generator alternator there. So in this case, that yellow wire has been known notoriously for being a problem because that wire goes all the way from the bulkhead on the passenger side, down the engine block, around underneath on an envelope, the crankshaft, and over to the driver's side of the engine to get to the generator, and that yellow wire could be open. So that's a 2012. And then when you look at a 2017, here you can see there's that yellow wire, but note something there. It has changed in wire. Let's go back here. These are called Gen Coms, if you notice right there. And here you can see these are called a Gen RC and Gen LI. So if you don't know what you're supposed to be doing, did you know that the Ford service manual does give you pinpoint tests on how to learn this? So do me a favor. If you know you suck at charging systems and starting systems, but charging system in this case, will you please start looking up these charts and start learning from them? Because Ford does offer these pinpoint tests on how to test that generator and know what each wire is for. Maybe in a future class, I'll go over how this all works. As a matter of fact, maybe I will. And in this case, you want to know what's going on there so you know how to test these, because it's a sin that y'all want to know common, or you want to know the high-tech stuff, but yet you don't know old technology like how an alternator generator works, you know. So please make a note of that, as I hear shop owners frustrated that, you know, one shop was telling me how their Napa is ready to cut them off because their return on their alternator generators, where there's nothing wrong with them, all because we're not testing these circuits or know how to test that circuit. So that's a crime, guys, really. So there you go. And those of you that know the old trick, actually, that was not the last one. This is the last one, I think. I just got off on all these. These were pretty good going back in time, and also new stuff. Is that as there's a Power Stroke 6.7, if you ever find yourself with a no communication, no crank, no start, disconnect that middle terminal. Yeah. All communication takes place on the body connector right there. This is your engine connector. So a tip that we have found to see if we have a short that's causing this is simply pull that engine connector off and tell me if it cranks and if it also communicates. If it does, then you definitely got to shorten that harness somewhere that needs to be figured out. And that's another story for later, but that's a good start. This works for Power Stroke 6.7s and also for the Power Stroke 6.0s, not 6.4s, 6.0s and 6.7s. Now, in 2022, there's been a serious change in the computer wiring. They're similar, but I haven't been verified. So this works up to 21 models. Okay, so be aware of that. I'm done, Mr. David.
Wow, that was very, very interesting for me anyway. And I would presume for those audience members, that was also very interesting. Thank you very much for all of that great information, Tony. Just as a by the way, if you missed any part of this presentation and or you wanted to listen to it again, you want to share it with other individuals in your shop, we will be posting this together with all of the other webinars that Tony has produced for us on our website, our YouTube website, Lucas Diesel Service website, YouTube channel, and Tony also has them on his website. So keep that in mind. We have a couple of either in questions. One of them, Tony, somebody was asking, which scan tool is this? The one that you were showing, I believe, the
IDS. That was IDS.
IDS.
The Ford
Okay.
IDS. Mm-hmm.
Very good. Oh, you answered that one. So sorry, I didn't see that.
Okay.
And then somebody said also 5.9 rolling idle, which agreed often is VCV or FCA. We have seen a bad fan clutch that has also
Yeah.
caused surging.
I agree with that. Yep.
Very good. I think one of the messages here on your presentation that we take away from your presentation is something I learned from maybe one of your original classes, and that was check the basics first, right? Filters, battery, so forth. Check all the basics first. And then, as you described, the individual who was losing 10,000 in one month there, training, 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 right? All that scratching of the head costs you big bucks. And a little bit of training for, a few $100, $1,000 would save you that that 10 grand, right, Tony?
Yes, sir.
Yeah. All right, for those of you who are here for the presentation starting at the very, very beginning, I showed you a QR code for some new catalogs that we have available. So if you want a paper copy of the catalog, please either call Erica or send her an email, call me or send me an email. The information here is on the screen. If you forget all of this, well, then we will be posting the webinar on our webpage, and you can go back to either this QR code and you can scan that and get an electronic copy, or you can give us a call and here's the information. So once again, thank you very much for taking time out of your day to participate in this training. I think that this training is invaluable, and that's my personal opinion. But I think it's great. You do a great job, Tony, and we very much appreciate your information and all that you do for us.
Thank
Okay,
you.
thanks once again, and we'll see you all in about a month's time. Thank you. Have a good rest of the day.
Thank you.